Audiobook Science Class 8 Page 44 Chapter 4 Materials Metals and Non-metals. You are familiar with a number of materials like iron, aluminium, copper, etc. Some materials have been given in Table 4.1. Table 4.1 Appearance and Hardness of Materials. There are 3 columns. The first one is Object or Material. Second is Appearance, shiny or dull. The third one is Hardness, very hard or not very hard. For your convenience, we have given 5 object or material, which are iron, coal, sulfur, aluminium and copper. Now, complete the table in your notebook by filling the columns Appearance and Hardness. Can you name the materials which are metals? The rest of the materials in Table 4.1 are non-metals. Metals can be distinguished from non-metals on the basis of their physical and chemical properties. Recall that luster and hardness are physical properties. 4.1 Physical properties of metals and non-metals. Have you ever seen a blacksmith beating an iron piece or an article made up of iron, like a spade, a shovel, an axe? Do you find a change in the shape of these articles on beating? Would you expect a similar change if we try to beat a piece of coal? Let us find out. Activity 4.1. Take a small iron nail, a coal piece, a piece of thick aluminium wire and a pencil lead. Beat the iron nail with a hammer as shown in figure 4.1, but take care that you don't hurt yourself in the process. Try to hit hard. Hit hard the aluminium wire also. Then repeat the same kind of treatment on the coal piece and pencil lead. Record your observations in Table 4.2. Figure 4.1. Beating an iron nail with hammer. Now, Table 4.2. Malleability of materials. We have 2 columns. The first one is for object or material and the second is for change in shape. Flattens, breaks into pieces. In the object or material column, the number 1 item is iron nail, second, coal piece, third, aluminium wire, fourth, pencil lead. Now complete the table in your notebook by filling the correct answer in front of each material or object. Page 45. You saw that the shape of the iron nail and the aluminium wire changed on beating. If they were beaten harder, these could be changed into sheets. You might be familiar with silver foil used for decorating sweets. You must also be familiar with the aluminium foil used for wrapping food. The property of metals by which they can be beaten into thin sheets is called malleability. This is a characteristic property of metals. As you must have noticed, materials like coal and pencil lead do not show this property. Can we call these metals? Can you hold a hot metallic pan which is without a plastic or a wooden handle and not get hurt? Perhaps not. Why? Try to list some other experiences in which a wooden or plastic handle protects you from being hurt while handling hot things. On the basis of these experiences, what can you say about the conduction of heat by wood and plastic? You must have seen an electrician using his screwdriver. What kind of handle does it have? Why? Let us find out. Activity 4.2. Recall how to make an electric circuit to test whether electricity can pass through an object or not, as shown in figure 4.2. You might have performed the activity with various objects in class 6. Now, repeat the activity with the materials mentioned in Table 4.3. Observe and group these materials into good conductors and poor conductors. Figure 4.2 shows an electric tester. Now, Table 4.3. Electrical conductivity of materials. There are 3 columns. First is for serial number, second materials, and the third is for good conductor or poor conductor. First, iron rod or nail. Second, sulfur. Third, coal piece. Fourth, copper wire. Now complete this table in your notebook by giving correct answers against each material. You observe that iron rod, nail, and copper wire are good conductors, while rolled sulfur piece and coal piece are poor conductors. Haley is surprised.
Oh, the meaning of recalling our experiences and then of this activity was to show that metals are good conductors of heat and electricity. We learned this in class 6.
Where do you find the use of aluminium and copper wires? Have you seen wires of coal? Definitely not. The property of metal by which it can be drawn into wires is called ductility. Have you ever noticed the difference in sound on dropping an iron sheet or plate, a metal coin, and a piece of coal on the floor? If not, you can try it now. Do you note any difference in the sound produced? Page 46. Have you seen wooden bells in temples? Can you give a reason? The things made of metals produce a ringing sound when struck hard. Suppose you have 2 boxes similar in appearance, one made of wood and the other of metal. Can you tell which box is made of metal by striking both the boxes? Since metals produce ringing sounds, they are said to be sonorous. The materials other than metals are not sonorous. After performing the above activities, we can say that some materials are hard, lustrous, malleable, ductile, sonorous, and good conductors of heat and electricity. The materials which generally possess these properties are called metals. The examples of metals are iron, copper, aluminium, calcium, magnesium, etc. In contrast, materials like coal and sulfur are soft and dull in appearance. They break down into a powdery mass on tapping with a hammer. They are not sonorous and are poor conductors of heat and electricity. These materials are called non-metals. The examples of non-metals are sulfur, carbon, oxygen, phosphorus, etc. Metals like sodium and potassium are soft and can be cut with a knife. Mercury is the only metal which is found in liquid state at room temperature. These are exceptions. 4.2. Chemical properties of metals and non-metals. Reaction with oxygen. You are familiar with the phenomenon of rusting of iron. Recall the reaction by which rust is formed. You had also performed in class 7 an activity of burning a magnesium ribbon in air. You had learnt that in both the processes oxide formation takes place. Complete the following reactions of iron and magnesium with oxygen. Iron Fe plus oxygen O2 plus water H2O gives magnesium Mg plus oxygen O2 gives Activity 4.3. Let us check the nature of rust formed as a result of the reaction between iron, oxygen and water. Collect a spoonful of rust and dissolve it in a very little amount of water. You will find that the rust remains suspended in water. Shake the suspension well. Test the solution with red and blue litmus papers, as shown in figure 4.3. What do you observe? Is the solution acidic or basic? Figure 4.3. Testing the nature of rust. It has 3 images. The first one shows rust suspension, the second shows red litmus paper, and finally the third one shows rust. Page 47. Now, Paheli has a question.
Does copper also get rusted? I have seen a greenish deposit on the surface of copper vessels.
When a copper vessel is exposed to moist air for long, it acquires a dull green coating. The green material is a mixture of a copper hydroxide, CuOH2, and a copper carbonate, CuCO3. The following is the reaction 2Cu plus H2O plus CO2 plus O2 gives CuOH2 plus CuCO3. Here, H2O plus CO2 plus O2 is moist air. Now, recall the activity of burning magnesium ribbon. The ash obtained on burning magnesium ribbon is dissolved in water and tested for its acidic or basic nature. Is the solution acidic or basic? How do you ascertain this? You must have observed that the red litmus turns blue. So, oxide of magnesium is also basic in nature. In general, metallic oxides are basic in nature. Let us now observe the reaction of nonmetals with oxygen. Activity 4.4. To be demonstrated by the teacher in the class. Take a small amount of powdered sulfur in a deflagrating spoon and heat it. If deflagrating spoon is not available, you may take a metallic cap of any bottle and wrap a metallic wire around it and give it the shape shown in figure 4.4a. As soon as sulfur starts burning, introduce the spoon into a glass jar or glass tumbler, as shown in figure 4.4a. Cover the tumbler with the lid to ensure that the gas produced does not escape. Remove the spoon after some time. Add a small quantity of water into the tumbler and quickly replace the lid. Shake the tumbler well. Check the solution with red and blue litmus papers, as shown in figure 4.4b. Figure 4.4a. Burning of sulfur powder. In the image, an improvised deflagrating spoon. Figure 4.4b. Testing of solution with litmus papers. Page 48. Table 4.4. Metals and non-metals in acids and bases. The table has 5 columns. The first one is for serial number, second for name of the base, third for metal, fourth name of the acid, and fifth non-metal. Complete the table in your notebook. One is done for you. Example, serial number 1, name of the base, calcium hydroxide, metal, calcium, name of the acid, sulfuric acid, non-metal, sulfur. The name of the product formed in the reaction of sulfur and oxygen is sulfur dioxide gas. When sulfur dioxide is dissolved in water, sulfurous acid is formed. The reaction can be given as follows. Sulfur dioxide, SO2 plus water, H2O gives sulfurous acid, H2SO3. The sulfurous acid turns blue litmus paper red. Generally, oxides of nonmetals are acidic in nature. Recall the name of some of the laboratory acids and bases you have read in class 7. Note down their names in table 4.4. Identify the metal or non-metal present in them, which forms oxides with oxygen. Reaction with water. Let us see how metals and non-metals react with water. Sodium metal is very reactive. It reacts vigorously with oxygen and water. A lot of heat is generated in the reaction. It is, therefore, stored in kerosene. Activity 4.5. To be demonstrated by the teacher. During demonstration, Special care should be taken that the size of the sodium metal piece is roughly the size of a wheat grain. It should be held with a pair of tongs. Take a 250 ml beaker or glass tumbler. Fill half of it with water. Now carefully cut a small piece of sodium metal. Dry it using filter paper and wrap it in a small piece of cotton. Put the sodium piece wrapped in cotton into the beaker. Observe carefully. During observation, keep away from the beaker. When reaction stops touch the beaker, what do you feel? Has the beaker become hot? Test the solution with red and blue litmus papers. Is the solution acidic or basic? Figure 4.5. Reaction of sodium with water. Page 49. You observed that sodium reacts vigorously with water. Some other metals do not do so. For example, iron reacts with water slowly. Generally, nonmetals do not react with water, though they may be very reactive in air. Such nonmetals are stored in water. For example, phosphorus is a very reactive nonmetal. It catches fire if exposed to air. To prevent the contact of phosphorus with atmospheric oxygen, it is stored in water. Activity 4.6. Warning. Keep the mouth of the test tube away from your face. Use test tube holder to hold the test tube. Take samples of metals and non-metals listed in table 4.5 in separate test tubes and label them as A, B, C, D, E and F. With the help of a dropper, add 5 ml of dilute hydrochloric acid to each test tube one by one. Observe the reactions carefully. If no reaction occurs in the cold solution, warm the test tube gently. Bring a burning matchstick near the mouth of each test tube. Repeat the same activity using dilute sulfuric acid instead of the dilute hydrochloric acid. Record your observations in Table 4.5. Table 4.5. Reaction of metals and nonmetals with acids. The table has 4 main columns. The first one, test tube label. Second, for metal or non-metal. Third, for reaction with dilute hydrochloric acid. It has 2 sub-columns, the first one being room temperature, second, warm. Fourth, reaction with dilute sulfuric acid. This also has 2 sub-columns, room temperature and warm. Now, we have given you 6 metal or non-metals. A. Magnesium ribbon. B. Aluminium foil. C. Iron fillings. D. Copper peeled flexible wire. E. Charcoal powder. F. Sulfur powder. Now, make the table as just described and fill the rest of the columns in your notebook. Page 50. Reaction with acids. Is there a difference in the way metals and nonmetals react with acids? What could the pop sound in some cases be due to when a burning matchstick is brought near the mouth of the test tubes? You must have found that nonmetals generally do not react with acids, but metals react with acids and produce hydrogen gas that burns with a pop sound. You must have noticed that copper does not react with dilute hydrochloric acid even on heating, but it reacts with sulfuric acid. Reactions with bases. Activity 4.7. To be demonstrated by the teacher. During the preparation of sodium hydroxide solution, care should be taken that pellets of sodium hydroxide are handled with the plastic spatula. Prepare a fresh solution of sodium hydroxide in a test tube by dissolving 3 to 4 pellets of it in 5 ml of water. Drop a piece of aluminium foil into it. Bring a burning matchstick near the mouth of the test tube. Observe carefully. What does the pop sound indicate? As before, the pop sound indicates the presence of hydrogen gas. Metals react with sodium hydroxide to produce hydrogen gas. Reactions of nonmetals with bases are complex. Displacement reactions. Recall the activity of the reaction between copper sulfate and iron that you performed in class 7. Let us observe some more reactions of that kind. Activity 4.8. Take 500 ml beakers and label them A, B, C, D and E. Take about 50 ml of water in each beaker. Dissolve in each beaker a teaspoonful of each substance as indicated in figure 4.6a. Keep the beakers undisturbed for some time. Record your observations in your notebook. Figure 4.6a and b shows displacement reactions. Beaker A. Copper sulfate CuSO4 plus zinc granule Zn. Beaker B. Copper sulfate CuSO4 plus iron nail Fe. Beaker C. Zinc sulfate ZnSO4 plus copper turnings Cu. Beaker D. Iron sulfate FeSO4 plus copper turnings Cu. Beaker E. Zinc sulfate ZnSO4 plus iron nail Fe. Page 51. What changes do you observe in the various beakers? You have read that one metal displaces another metal from its compound in aqueous solution. In beaker A, zinc Zn replaces copper Cu from copper sulfate CuSO4. That is why the blue color of copper sulfate disappears and a powdery red mass of copper is deposited at the bottom of the beaker. The reaction can be represented as copper sulfate CuSO4 plus zinc Zn gives zinc sulfate ZnSO4 colorless plus copper Cu red. You can write down the reaction taking place in beaker B in a similar manner. Haley has something to say.
I have understood the reactions taking place in beakers A and B, but I'm still confused why there is no change in beakers C, D and E.
There could have been displacement of zinc by copper in beaker C and by iron in beaker E. Similarly, iron could be displaced by copper in beaker D. Since we do not see any change in beaker C, we can infer that copper is not able to replace zinc from zinc sulfate. But why? When zinc can replace copper in beaker E, why cannot copper replace zinc in beaker C? Remember that science is not arbitrary. It follows definite rules based on facts. And the rule here is that zinc is more reactive than copper and iron. A more reactive metal can replace a less reactive metal, but a less reactive one cannot replace a more reactive metal. Now, you can understand why there are no displacement reactions in beakers D and E also. Can you guess the sequence of metals from more reactive to less reactive among zinc, iron and copper? 4.3. Uses of metals and non-metals. You should be able to guess why metals are used in making machinery, automobiles, aeroplanes, trains, satellites, industrial gadgets, cooking utensils, water boilers, etc. You are also familiar with the uses of some non-metals. Here are some interesting ones. We are sure that you will guess them right. Non-metal is essential for our life, which all living beings inhale during breathing. Non-metals used in fertilizers to enhance the growth of plants. Non-metal used in water purification process. Non-metal used in the purple-colored solution which is applied on wounds as an antiseptic. Non-metals used in crackers. You may add some more uses of metals and non-metals from your experiences. Page 52. Paheli says, I heard that magnesium is found in plants. In what form is it found in them? Even Bujo has something to say. The doctor reported iron deficiency in my body. Where is iron in my body? In class 7, you have learnt that in a chemical reaction, new substances are formed. These substances are different from those which underwent the reaction. Now, if a substance cannot be broken down further by chemical reactions, by cooling, heating, or by electrolysis, it is called element. Sulfur is an element. So is iron. Carbon too is an element. The smallest unit of an element is atom. A sample of an element contains only one kind of atom. The atom of an element remains unaffected by physical changes in the element. For example, an atom of liquid sulfur would be exactly the same as the atom of solid or vapor sulfur. Although we have an infinite variety of substances in the universe, the number of elements forming these substances is limited. There are no more than 94 naturally occurring elements. An important classification of elements is in terms of metals and non-metals. Most of the elements are metals. The remaining are either non-metals or metalloids. Metalloids possess character of both metals and non-metals. Page 53. Keywords: atom, conductor, displacement reaction, ductility, elements, hardness, malleability, metals, metalloids, non-metals, sonorous. What you have learnt: metals are lustrous, whereas non-metals have no luster. Generally, metals are malleable and ductile. Non-metals do not have these properties. Generally, metals are good conductors of heat and electricity, but non-metals are poor conductors. On burning, metals react with oxygen to produce metal oxides, which are basic in nature. Non-metals react with oxygen to produce non-metallic oxides, which are acidic in nature. Some metals react with water to produce metal hydroxides and hydrogen gas. Generally, non-metals do not react with water. Metals react with acids and produce metal salts and hydrogen gas. Generally, non-metals do not react with acids. Some metals react with bases to produce hydrogen gas. More reactive metals displace less reactive metals from their compounds in aqueous solutions. Metals and non-metals are used widely in everyday life. Exercises. 1. Which of the following can be beaten into thin sheets? A. Zinc. B. Phosphorus. C. Sulfur. D. Oxygen. 2. Which of the following statements is correct? A. All metals are ductile. B. All non-metals are ductile. C. Generally, metals are ductile. D. Some non-metals are ductile. Page 54. 3. Fill in the blanks. A. Phosphorus is a very blank non-metal. B. Metals are blank conductors of heat and blank. C. Iron is blank reactive than copper. D. Metals react with acids to produce blank gas. 4. Mark T if the statement is true and F if it is false. A. Generally, nonmetals can react with acids. B. Sodium is a very reactive metal. C. Copper displaces zinc from zinc sulfate solution. D. Coal can be drawn into wires. 5. Some properties are listed in the following table. Distinguish between metals and nonmetals on the basis of these properties. Column number 1, properties. Column number 2, metals. Column number 3, nonmetals. First property, appearance. Second, hardness. 3, malleability. 4, ductility. 5, heat conduction. 6, conduction of electricity. 6. Give reasons for the following. A. Aluminium foils are used to wrap food items. B. Immersion rods for heating liquids are made up of metallic substances. C. Copper cannot displace zinc from its salt solution. D. Sodium and potassium are stored in kerosene. 7. Can you store lemon pickle in an aluminium utensil? Explain. 8. Match the substances given in column A with their uses given in column B. Column A. 1. Gold. 2. Iron. 3. Aluminium. 4. Carbon. 5. Copper. 6. Mercury. Column B. A. Thermometers. B. Electric wire. C. Wrapping food. D. Jewelry. E. Machinery. F. Fuel. Page 55. 9. What happens when A. Dilute sulfuric acid is poured on a copper plate. B. Iron nails are placed in copper sulfate solution. Write word equations of the reactions involved. 10. Saloni took a piece of burning charcoal and collected the gas evolved in a test tube. A. How will she find the nature of the gas? B. Write down word equations of all the reactions taking place in this process. 11. One day, Rita went to a jeweler's shop with her mother. Her mother gave an old gold jewelry to the goldsmith to polish. Next day, when they brought the jewelry back, they found that there was a slight loss in its weight. Can you suggest a reason for the loss in weight? Extended learning, activities and projects. First, prepare index cards for any 4 metals and 4 non-metals. Second, visit a blacksmith and observe how metals are molded. Third, suggest an experiment to compare the conductivity of electricity by iron, copper, aluminium and zinc. Perform the experiment and prepare a short report on the results. Fourth, find out the locations of the deposits of iron, aluminium and zinc in India. Mark these in an outline map of India. In which form are the deposits found? Discuss in the class. Fifth, discuss with your parents or neighbors or goldsmiths why gold is preferred for making jewelry. 6. Visit the following websites and enjoy the quiz on metals and non-metals. chemistry.about.com/od/tests/quizzes/quizzes.htm www.gcseScience.com/q/QUSEMET.html www.corrosionsource.com handbook/periodic/metals.htm. Chapter 4 ends here.